Hello students, greetings of the day. This is your Rani Rao, faculty in physics, okay, from VIP classes. Okay. Yeah, today we'll talk about application of derivatives in physics and integration, concept of integration. And last in my first and second part videos of derivatives, you can go through my channel. Okay. So we'll come across differentiation formulas and applications we have seen. Now, a few more applications, okay, of derivatives in physics. Now you see. या बच्चों सो टुडे आज हम पार्ट 1 पार्ट 2 के बाद सो पार्ट 3 के बारे में डेरिवेटिव्स के एप्लीकेशंस के बारे में हम सुनेंगे ओके अब देखिए ए पोजीशन ऑफ पार्टिकल इज गिवन बाय 30 स्क्वायर प्लस 40 माइनस 1 सो फाइंड इट्स इनिशियल वेलोसिटी एंड इनिशियल एक्सेलरेशन सो हमें पोजीशन फंक्शन ऑफ टाइम दिया गया है इसमें से हम क्या निकालना है फाइंड इट्स इनिशियल वेलोसिटी एंड इनिशियल एक्सेलरेशन सी व्हेनेवर इन फिजिक्स कभी भी अगर हम इनिशियल के बारे में बात किया तो टाइम t = 0 रखना है व्हेनेवर यू to find initial keep t is equal to 0. Now the given function x value you can write down 3t square plus 4t minus 1 right so for initial velocity what will be velocity v is equal to dx by dt so differentiate this one so 3 into d by dt of t square is 2t plus 4 into d by dt of t is 1 d by dt of constant is 0 so how much you will get 60 plus 4 this is what velocity of the particle is asking initial velocity initial का मतलब क्या है starting time के पास कितना होगा so t is equal 0 के पास पूछ रहा है so velocity at t is equal 0 is called initial velocity so 6 into 0 plus 4 that is equal to 4 meter per second now if you draw a number line here you can see number line over here so now if you consider this is x is equal 0 at t is equal 0 if you consider where the particle is at t is equal to 0 if you keep here x becomes now this entire term becomes 0 3t square plus 40 and becomes minus 1 means particle at t is equal 0 it was at x is equal minus 1 and how much velocity positive that means this particle at t is equal 0 okay so going in what direction positive x direction with what velocity initial velocity that is 4 meter per second this is the meaning of this okay next asking initial acceleration yes so what do you by acceleration acceleration means dv by dt isn't it differentiate this velocity expression now 6 into d by dt of t is 1 plus constant is 0 this is 6 meter per second square so it's uniform acceleration not only t is equal 0 throughout the motion acceleration will be 6 meter per second square okay this is how we attempt the question right now next you can see if position of particle is given by this much t cube minus 36 t square plus 30t minus 1 find velocity when acceleration becomes 0 so find no issue first of all find the velocity what is velocity dx by dt differentiate d by dt of d by dt of t cube minus 36t square plus 30t minus 1 है ना इसको भी निकालिए d by dt of t cube कितना होता है that is 3t square minus 36 into d by dt of t square how much that is 2t होगा so plus 30 into d by dt of t कितना that is 1 minus 0 so ये हो जाएगा 3t square minus 72t plus 30 this is the velocity of the body he's asking what is find its velocity and acceleration becomes 0 so differentiate this again for velocity how do we get acceleration now so acceleration is equal to dv by dt if I differentiate this expression d by dt of t square कितना होगा 2t minus 72 d by dt of t is 1 constant का differentiation होगा है ना तब क्या हो जाएगा बोलो तब क्या हो जाएगा बोलो 60 minus 70 this is acceleration so when acceleration becomes 0 what is velocity first when after finding the value of acceleration हमें क्या करना है इसको 0 निकालना है तो क्या हो जाएगा इसमें समय कितना आएगा बोलो इसको हम 0 किए तो 60 is equal to 72 होगा इसमें से 60 कितना होगा 6 1 जा 6 2 जा 12 सेकंड इस 12 सेकंड्स के वक्त हमें क्या चाहिए वेलोसिटी चाहिए तो इसे सब्स्टिट्यूट करो इसमें तो क्या हो जाएगा आपको so for finding okay just I will find here Now therefore just I will write here, okay?
Now therefore
so
just
velocity is equal to 3 into 12 square.
3 into 12
okay?
square.
Minus 72 into
Minus
12.
72
Plus
into
30.
12.
Just simplify,
Plus
we'll
30.
get what?
Just simplify,
its
we'll
velocity
get what?
when acceleration
Its
becomes
velocity
0.
when acceleration.
So acceleration becoming 0 after 12 seconds. At that instant, what is the velocity?
At that instant, what is the velocity? Substitute in the function of velocity.
Right, hope you will do this. Yeah.
Right, hope you will do this.
Now coming for next question, you see.
Now coming for
so
next
as we have
question,
seen,
you see.
differentiation means rate measure, right? So area of a circle is given as pi r square. How fast is the area changing?
How fast is the
With respect
area
to radius
changing?
when the radius is 10 meters.
Radius when the radius is 10
So when
meters.
radius is changing, no,
So
when
when
radius
radius is
increases,
changing,
area
when radius
increases.
increases,
When radius decreases, area
when radius
decreases. The rate
decreases,
at
area
which
decreases. The
okay,
rate
area
at
is
which
changing. dA
okay,
by
area
dt
is
is
changing.
equal to
dA by
d by
dt is
dt
equal
of how much
to d
rate?
by dt
Pi
of
r
how much
square.
rate?
This
Pi
pi
r
is
square.
constant. d by
This
dt
pi
of
is
r square
constant.
is
d by dt
2r
of r square is
into what?
2r
dr by
what?
dt.
dr
This
by
is
dt.
2 pi r
This is
into what?
2 pi
d.
r
So
into
this
what?
is the what? The rate
So
at
this
which
is the what? The
area
rate
is
at
changing.
which
dA by
area
dt.
is changing. dA
So
by
he's
dt.
asking this value.
So
he's
he's
asking this value when
He's asking this
radius
value
is 10
when
meters. Substitute here.
radius is 10
So
meters.
therefore,
Substitute
dA
here. So
by
therefore,
dt
dA
at
by
r 10
dt
meters is
at
equal
r
to
10 meters
2
is
pi m
equal
into.
to 2 pi m into.
So here one thing, small thing, right?
So here one thing,
so
small
like,
thing, right?
As a physics
So
teacher,
like,
no, rate of
as a
change
physics
of r
teacher,
means
no, rate
always
of
this
change of
velocity.
r
Okay?
means always
Don't
this
do this
velocity,
mistake
okay?
here.
Don't do
2
this
r
mistake here.
into d
2
by
r into
how
d
fast
by
area with respect
how
to
fast
radius,
area with
not with
respect to
respect to time.
radius. Not
So you make it
time.
this dA
So you
by
make
d
it
by
this
dr
dA
of
by
pi
d
r
by
square.
dr
Okay?
of pi r
So d
square,
by
okay?
dr of.
So d by
d by
dr
pi
of.
into d by
So d
dr
by
of
pi
r square
into
is
d
2r
by
into
dr of r
dr
square is
by
2r
dr.
into
This value
dr
becomes
by
1 by
dr. This value
this will
becomes
be 2
1
pi
by
r.
this will be 2 pi r.
Okay.
Okay.
Hope you are getting here. Now substitute the value of your r.
Substitute the value of your
This is 2 pi
r.
into r value how much is saying?
Into
10
r value how
meters,
much
which
is
is
saying?
equal to
10
20
meters,
pi.
which is equal to 20
Okay?
pi.
Yeah.
Okay?
So this is dA by dr. Keep it
So
in
this
mind.
is dA by dr.
Let's find the slope of the tangent
Find the
curve at
slope
y
of
is
the
equal to x
tangent
square
curve
plus
at
2x
y is
plus
equal
4
to
and
x
x is
square
equal
plus
0 and
2x
x is
plus
equal
4
to
and x
minus
is
1.
equal to 0 and x is
See,
equal to minus
the
1.
variation of
See,
y with respect
the
to x is
variation of
called
y with
what?
respect to x is
Variation
called
value
what?
of the y with
Variation
x is
value
called what?
of
dy
y
by
with
dx.
x
This
is
is
called what?
is
dy
called
by
what?
dx. This
Slope of
is called
yx
what?
graph.
Slope of yx graph.
Slope of what graph?
Slope of what graph?
Yx graph. So that
Yx
is,
graph.
now if you differentiate, what will get? Slope is equal to
slope is equal
d
to
by dx
d
of
by
this curve.
dx of this
X
curve.
square plus 2x
X
plus 4.
square
Differentiate
plus
this
2x
one.
plus 4.
That
Differentiate
is
this one.
2x plus 2.
That is
So this
2x
value of
plus 2.
slope.
So this
Okay, if you
value
take
of
any this
slope.
curve, you have to
Okay,
draw
if
the
you take any
curve.
this curve,
Okay?
you have to draw the
So
curve.
some
Okay?
arbitrary curve if you get
So
for
some
y x
arbitrary
equal
curve
x
if
is
you
equal
get for
0,
y
y
is
is
equal
equal
x is
4.
equal 0, y is
Okay?
equal 4.
Like x 0, x is equal 1,
Like
x is
x0, x
equal
is
2,
equal
x is
1,
equal
x is
3. x
equal
0
2,
means
x
y
is
is
equal
equal to how much?
x0 means y is
x
equal to how
0
much?
means y is 4.
x0 means y
So
is
y
4.
value some 4.
So
Somewhere
y
else.
value some 4 somewhere else.
x1, 1 plus 2, 3
x1,
plus 4,
1
y
plus
7.
2, 3 plus 4, y 7.
x is equal to 1 means y
x is
7
equal
some
to
what,
1
okay?
means y 7
x is equal to लगा दो 4 plus 4 8 8 plus 4 12. So when x is equal to y is equal some 12 somewhere. So we'll get a curve like this
So
sometime.
we'll get a curve
Okay?
like this sometime.
And he's asking slope at x is equal to 0 origin. If you draw a tangent here,
If you draw a tangent
if you draw a tangent for this
if you
curve
draw a
at
tangent
this
for
point,
this curve at this point.
x is equal to 0. If
X
you
is equal
consider
to
draw a
0.
horizontal,
So
this
consider
angle,
draw a
tangent
horizontal,
of
this
theta, tan
angle,
theta is
tangent
slope.
of theta, tan
So
theta is slope.
slope at x
So
is equal to
slope
how
at
much?
x is equal
0.
to how much?
Is
0. Is
excuse me.
excuse me.
So 2 into 0
So
plus
2
2,
into
which is
0
equal to 2.
plus 2, which is equal
So
to
slope value, the theta is
slope
equal
value.
to find the
The
slope of
theta
the
is
curve is
equal
tan
to find the
theta.
slope
Tan
of
theta
the
is
curve
2.
is tan theta. Tan
X
theta
is
is
equal
2.
minus 1. Put slope at x is equal
minus 1.
minus
Put
1.
slope at x is equal minus 1.
So 2 into minus 1
So 2
plus
into
2 that is
minus
0.
1 plus 2
At x is equal 1 0 means
At x
almost
is
the
equal 1
straight
0
line
means
becomes what?
almost the straight line becomes what?
Horizontal. Slope 0 means what?
Horizontal.
The
Slope
straight line
0
becomes
means what?
almost here
The
becomes
straight
at
line
x is
becomes
equal
almost here
1.
becomes at
So
x is
graph
equal
no.
1.
So like this.
So graph no. So like
like
this.
this.
somewhat.
It will be like
So
the slope
like
if you draw
this.
tangent no.
Like
At
the
x
slope
is
if you draw
equal 1.
tangent no. At x is
At x is
equal
equal 1. The slope
X
becoming
is equal
0.
1. The slope becoming
I'll see
0.
how to find it.
Okay. I'll see how to find it.
Now we'll try to understand
Now,
what is the
try
concept
to
of
understand what is the
integration.
concept of integration.
Now you see students.
Okay.
So
Now you
here
see students,
integration means
so here
always.
integration means always.
What is the method of
What is the
finding the
method of
area?
okay finding the
See,
area.
we have seen स्लोप वेरिएशन वैल्यू ऑफ y विद रिस्पेक्ट टू x दैट इज कॉल्ड क्या बोलते हैं उसको स्लोप बोलते हैं एक वैल्यू y x के साथ कैसा चेंज हो रहा है उसका रेट ऑफ चेंज जो है ना उसको हम डिफरेंशिएशन बोलते हैं उनकी बात करें इंटीग्रेशन क्या होता है फर्स्ट ऑफ ऑल इंटीग्रेशन जो चीज है ना पहले मैथमेटिक्स में एरिया फाइंड आउट करने के लिए एक टेक्निक जो फाइंड आउट किया गया है वो है इंटीग्रेशन
गया है वो है integration.
So for finding the area of
So for
irregular
finding
shaped
the area
objects,
of
you know,
irregular shaped
regular
objects,
shaped
you know,
objects area, you know,
regular shaped
triangle area,
objects
half
area, you
into
know,
base
triangle
into
area,
height,
half into base into
rectangle
height,
area, length into breadth,
rectangle area, length
okay,
into breadth,
trapezium area,
okay,
half into a plus
trapezium
b
area,
into
half
h.
into
So
a
what
plus
about
b
the
into
area
h. So
formed
what
by, for
about the
example,
area
if I
formed by,
have,
for example,
so
if
y
I
is
have,
equal to
so
f
y
of
is
x, some
equal to
curve is
f
here,
of x,
arbitrary
some
curve.
curve is here, arbitrary curve.
So if I ask you find the
So if I
area
ask
under
you
this
find
graph,
the area
okay,
under this
so
graph,
with y is
okay,
equal to f of x
so
with
with
x
y is equal to
axis.
f of x
So from
with x
starting say
axis.
0 to
So
some
from
value
starting
here.
say 0 to some value here, for
I want to
example.
find this area.
I want
By
to
the way,
find
we
this
don't have
area.
standard
By the
formula.
way, we don't have
So what
standard
this
formula.
integration technique
So what
says
this
is,
integration
method of
technique
integration
says
is,
method of
for finding this
integration is,
area from
for
x is
finding
equal
this
to here
area
to
from
here,
x is equal
so
to here to
entirely
here.
divide this
So
entire
entirely
area into
divide this
small
entire area
elemental
into
areas.
small elemental areas.
Okay, the small elemental
The
areas.
small elemental
How small you
areas.
make the dx,
How
this
small you
dx
make the
width, no.
dx, this dx
How
width,
much
no.
small you make,
How much
that
small
much this
you
become
make,
perfect
that much
rectangle.
this
Why?
become
Because look at the
perfect
board.
rectangle. Why?
So as
Because
we
look
are
at the
taking
board.
like this. If you take
So as
width
we
of the
are taking like
rectangle
this, if
more
you take
here,
width of the
like this,
rectangle
width if
more
it is
here,
more,
like this.
and
Width if it
delta
is
x
more,
is more here,
and delta x
then
is
there
more
exists
here.
two values for
Then there
value of
exists
y
two
here,
values for
not
value
single
of y
value.
here. Not
But
single
when you
value.
decrease this width, no,
But when you
it
decrease
becomes
this
very
width,
very
no,
small like
it
this,
becomes
very
very
small.
small
Single
like this,
value
very
of y
small.
exists.
Single value of y
So
exists.
that means every point,
So,
every
that means
point to
every
point,
point,
every
every
small
point
small
to point,
bits
means
also
every small
considered
bits
for
also
adding to area.
considered for
So
adding to area.
the technique of integration
So,
says
the
that
technique of integration
whenever you want
says
to
that
find the area under
whenever you want
irregular
to find
shaped
the area
objects,
under
अगर कभी भी
irregular
हमें
shaped objects,
एक
अगर
irregular
कभी भी
shaped
हमें
curve है,
एक irregular
x
shaped
axis के
curve
साथ
है,
कितना area
x
bound
axis
किया,
के साथ
तो
कितना
क्या
area
करना है,
bound
हमें जिस
किया,
point से
तो
जिस
क्या
point
करना है,
तक
हमें
पूछ
जिस
रहा है,
point से जिस point
उसको हम
तक पूछ रहा है,
small areas
उसको
में
हम
divide
small
करेंगे.
areas
जब
में
हम
divide करेंगे.
small elemental
जब हम
areas में divide कर रहे हैं
elemental
और
areas में
ये जो
divide
width
कर
है
रहे
ना
हैं,
बहुत
और
tends
ये जो
to zero
width
ले
है
रहे
ना
हैं, तो
बहुत tends
हर
to zero
small
ले
width
रहे
भी
हैं, तो
consider
हर
किया जा रहा
small
है.
width भी consider
So
किया
not
जा रहा
believing
है.
any small
So
single
not
bit
believing
also.
any small
You're getting?
single bit also. You're getting?
See, if you consider up
See,
to here
if you
perfect
consider
rectangle,
up
you know,
to
but
here
this triangle
perfect
area is
rectangle, you
missing
know,
here.
but this
But
triangle
also you have
area
to
is
add.
missing here.
But when you
Also
make
have
this
to
width
add.
very very
But when you
small
make
now, so
this
triangle
width
area
very, very small
almost
now, so
becomes zero
triangle
here.
area
You
almost
understand what I'm
becomes zero
saying?
here. You understand what I'm saying?
So when you are dividing like this, no,
When
so
you
you
are
are
dividing
having
like this,
up
no,
to this
so you are
triangle
having
for
up
rectangle
to this
formula, you know.
triangle for
This
rectangle
triangle
formula, you
formula
know.
with curve it
This
is, no,
triangle
we don't
formula
know.
with curve
That's
it is,
why
no, we
when
don't
you
know.
make this
That's
width
why
very small,
when you
no,
make
this
this
triangle
width
is
very
vanishing.
small, no, this
So
triangle is
every
vanishing.
becoming every
So
small
every
small
becoming
every
every
rectangle
small
strip
small
becoming.
every
Okay.
rectangle strip
So
becoming.
for small area we
So
can say
for
dA
small
is
area
equal
we
to
can say
with
dA
the
is
small
equal to
dx
with
with
the
the
small
small dx.
with
When
the small dx.
dx is tending to zero, the
dx
single
is
value
tending to
of y
zero,
is
the
coming
single
here.
value of y is
So
coming
area of the
here.
small element becomes
So
length
area of the
into
small
breadth, that
element
is
becomes
y
length into
into
breadth, that is
dx.
y into dx.
So such kind of small elemental
So
areas,
such
each
kind of
and every
small
first
elemental
strip,
areas, each and
second
every
strip, third
first
strip,
strip,
fourth
second
strip,
strip, third
n number
strip,
of
fourth
strips.
strip,
So
n
sum
number
of
of
all
strips.
these areas,
So sum of all
total
these
area
areas,
is sum of
total
all
area
these
is sum
areas.
of all
Okay,
these areas.
from 1 to
Okay,
long
from
n
1 to
infinity.
long n.
Under what condition? Delta x
Under what
tending to
condition?
0.
Delta x tending
Okay,
to 0.
so that under
Okay,
this condition,
so that under
so this
this
we can
condition,
call way of
so this
writing
we
in
can call
mathematics.
way of
Limit
writing in
delta x
mathematics.
tends to
Limit
0.
delta x tends to
Summation
0.
say I is equal to 1
Summation
to
say I
n
is
number,
equal
n
to
may
1
tends
to
to
n
infinity.
number, n may
So that is
tends to
I will
infinity.
write as
So that is I will
DAI.
write as
If I is equal to
DAI.
1, first
If I
strip
is
area
equal to 1,
DA1, I is
first
equal
strip area
to
DA1, I
second
is
strip
equal
area
to
DA2, I
second
is
strip
equal to
area
3,
DA2,
DA3,
I is
like
equal
that
to 3,
you can
DA3,
add
like
all the
that.
areas.
You can add
Sum
all
of
the
all
areas.
these areas.
Sum
This is
of all
totally-
these areas.
So this
is
summation
totally-
itself in
So
mathematics
this summation
we call
itself
as
in mathematics
integration
we
of
call
DA.
as integration
Sum of all DA,
Sum
DA,
of all
DA, DA, total area will get. For example, this
total
from
area
here
will
to
get.
here one,
For
no.
example, this
But
from
even
here to
small,
here one,
small,
no.
small, small
But even
element
small,
areas, no.
small
DA,
element
DA,
areas, no.
DA. If I add all these,
DA,
get
DA,
total
if I add
area.
all these, get
So
total
summation
area.
of all these
So
areas.
summation
use
of
what?
all these areas. Use what?
So integration of dA is
So
d.
integration of dA
Our
is
integration of dx is
Our
x. If
integration
x
of
length
dx
is
is
there,
x.
you are
If x
dividing
length
that
is
x
there,
length into
you are
small
dividing
small
that x
elements.
length into small elements.
Each of it dx. If at
Each of
all
it
this
dx.
dx, this
if you
dx,
add all
this
this
dx, this dx, this dx, this dx, total x will get the meaning of physical meaning is
the meaning of
integration of
physical
dx
meaning is
is x.
integration of dx
Zero
is
to
x from 0 to x.
Okay, the summation itself is
Okay,
called what?
the summation itself is called what?
So
Integration.
integration means the
So,
variation
integration
value
means
of
the
when you are
variation
finding
value of
some
when you are finding
basically
some,
for something is varying
for
means
something
for
is
small
varying
change
means
dx
for small change
we will
dx
calculate the change.
we'll
Total
calculate the
change means such kind of all
Total
small
changes,
small
such kind of
changes
all
we go on
small
adding.
small
It's
changes
called
we go on
total
adding.
chain.
That's
And in
called
mathematics
total chain.
language we
And
call
in
that
mathematics
itself as
language we call
integration.
that itself
Sum
as
of all the
integration.
changes.
Sum of all the
Total.
changes.
Okay, like
Total.
integrity.
Okay.
इंडिया का इंटीग्रिटी है ना मानते हैं ना. So united we for what stand divided we for what. Okay, division is differentiation, dividing and studying is differentiation. Okay, so studying small elemental changes and for studying total change, that is called total means integration, that means integration. Okay, this is what how we actually introduce the concept of integration. It is for finding total area, divide the total area into small elemental areas, add each and every area, adding summation, nothing but integration. Right. Okay. That's what I have shown here. No? Area under the curve is what? Area under the curve is what? Integration. Fine. So now here, in one sense, mathematics. Okay. Differentiation and integration. We can say in one sense they are inverse to each other. Because keep in mind this point, all of you. If I find say d by dx of some function, if I write, okay, regarding f of x, okay, some getting your g of x, okay. So if you write this meaning, small change in f of x is equal to g of x into dx. This is with respect to x. So with respect to small change in x dx and functional change d f of x, total change in functional value how much? That is integration. This integration. See here, differentiation, integration, cancellation. So only f of x. So whenever you differentiate a function, if you get some function g of x, if you integrate that function, okay, we'll get the same function. So differentiation, integration, inverse. So you can understand like this and keep in mind. For example, if I differentiate sin x, I got some g of x, cos x. So this meaning is, if I integrate this cos x with respect to x, cos x dx, I am going to get what beta? Sin x. Okay. So in mathematics, differentiation, integration, we use inverse in sense. If you differentiate a function, some function you are getting g of x. If you integrate that function, क्या मिल जाएगा आपको? Initial function मिल जाएगा. ऐसा अगर हमें एक फंक्शन का डेरिवेटिव पता है तो उस डेरिवेटिव जो रिजल्ट है ना उसको अगर हम इंटीग्रेट करें वो फंक्शन आ जाएगा. This is how we use the technique of differentiation and integration. So we'll have here by one मेथड यहाँ पर है आपको. अगर डिफरेंशिएशन के फार्मूला कुछ याद रखें तो आपको इंटीग्रेशन का फार्मूला आसान बन जाएगा. जैसे कि d by dx of sin x हम cos x बोल रहे हैं. cos x को इंटीग्रेट किया तो क्या आ रहा है? समझ में आई? तो इसलिए हम यहाँ अगर जो भी इंटीग्रल हम अब देखिए d by dx of f of x को मैं g of x बोला या f बोला और इस f dash of x को इंटीग्रेट किया तो क्या आ जाएगा? f of x आ जाएगा. एंड हम दो तरीके के इंटीग्रेशन बात करते हैं बच्चों. यहाँ एक है डेफिनेट इंटीग्रल जिसका वैल्यू हमें निश्चित से पता है, इसलिए डेफिनेट बोल रहे हैं. इसको लिमिट्स रहेंगे. अगर जिसको लिमिट्स नहीं है, हमें एग्जैक्ट वैल्यू पता नहीं, इनडेफिनेट इंटीग्रल, इसलिए सॉल्व करने के बाद हम कांस्टेंट को सी बोल के मानते हैं. तो वी आर हैविंग टू टाइप्स ऑफ इंटीग्रेशन. जब भी आप मान लीजिए फॉर एग्जांपल इसमें हम d by d of x स्क्वायर पता है, फार्मूला में 2x यहां देखिए अभी. तो अगर मैंने इसको ऐसा लिखा d of x स्क्वायर क्या हो जाएगा बेटा? 2x dx हो जाएगा. इस फंक्शन में अगर x में चेंज छोटा चेंज dx है तो इस फंक्शन y इज इक्वल टू x स्क्वायर में कितना है? d of x स्क्वायर, चेंज ऑफ x स्क्वायर, 2x है. अगर टोटल चेंज कितना होगा इसमें? टोटल चेंज कितना होगा इसमें? तो टोटल बोलते हैं इंटीग्रेशन मानेंगे. तो अभी इंटीग्रेशन ऑफ 2x dx क्या मिल गया आपको? डिफरेंस इंटीग्रल कैंसिल करो ना, क्या हो जाएगा? x स्क्वायर हो जाएगा. ठीक है, ऐसा डिफरेंशिएशन इंटीग्रेशन इनवर्स इन सेंस है. बात समझ में आ रही? इसको हम क्या लिखेंगे बोलते हैं? 2 जब लिखेंगे इंटीग्रेशन x dx x स्क्वायर बेटा. अगर लिमिट्स नहीं रहे तो प्लस. ठीक है बात. तो इसलिए हम इसको जनरलाइज भी कर सकते हैं. लेकिन कैसे जनरलाइज करेंगे? हम अगर इंटीग्रेशन x पावर n dx लिए तो इसका फॉर्मूला हो जाएगा x प्लस x पावर n प्लस 1 बाय n प्लस. इसके लिए आप इसको देखिए इंटीग्रेशन of x dx, इसका पावर कितना है? 1. So x power 1 plus 1 by 1 plus कितना आएगा? x स्क्वायर. So like this, just keep in mind as simple as in case of physics. अगर हमें मोस्टली जहाँ भी हम एरिया फाइंड आउट करना है, जहाँ भी हमें कुछ टोटल चेंज वेरिएशन फाइंड आउट करना है, तो थोड़ा स्मॉल चेंज dx रहा तो टोटल चेंज कितना होगा? इंटीग्रेशन. सो बेसिकली मैथमेटिक्स में इस इंटीग्रेशन टेक्निक को हमें एरिया ऑफ इरेगुलर शेप ऑब्जेक्ट्स और कर्व फाइंड आउट करने के लिए यूज कर रहे हैं.
करने
एंड
के लिए
हम
यूज कर रहे हैं।
यहाँ फिलहाल
एंड
फिजिक्स
हम
में
यहाँ फिलहाल फिजिक्स
डिफरेंशिएशन
में
हमें पता चल गया,
differentiation
इंटीग्रेशन
हमें पता
चीज
चल
क्या है
गया,
समझ लिए,
इंटीग्रेशन चीज
और
क्या
वो
है
जो
समझ
टेक्निक
लिए,
है ना
और वो
एरिया
जो
फाइंड आउट
टेक्निक है
करने
ना
का टेक्निक,
एरिया
कैसा
फाइंड आउट
करेंगे,
करने का टेक्निक,
टोटल
कैसा
एरिया को हम
करेंगे,
डिवाइड करेंगे,
टोटल एरिया को हम
तो
डिवाइड
स्मॉल
करेंगे,
एलिमेंट्स एरिया
तो
में
स्मॉल
एक छोटा सा
एरिया में
एलिमेंट लेंगे, उसका
एक
एरिया
छोटा
फाइंड
सा
करेंगे,
एलिमेंट लेंगे, उसका
उसको
एरिया
अगर
फाइंड करेंगे,
वैसे
उसको
बहुत
अगर
सारे छोटे
वैसे
छोटे छोटे
बहुत
एरियाज को
सारे
हम
छोटे
ऐड किए
छोटे
तो
छोटे एरियाज को
टोटल
हम
एरिया
ऐड
आ
किए तो
जाएगा। इस
टोटल एरिया आ
टोटल वे
जाएगा।
ऑफ
इस
कैलकुलेशन को
टोटल
हम
वे
बोलते
ऑफ
हैं
कैलकुलेशन को हम
समेशन,
बोलते हैं
उसको एक टेक्निकल में
समेशन, उसको
इंटीग्रेशन
एक
बोलते हैं
टेक्निकल में
मैथमेटिक्स में।
इंटीग्रेशन
ठीक
बोलते हैं
है, सो
मैथमेटिक्स
ऐसा
में।
है,
ठीक है,
दिस इज व्हाट
सो
टेक्निक ऑफ
ऐसा है,
इंटीग्रेशन।
दिस इज व्हाट टेक्निक ऑफ इंटीग्रेशन।
ने फॉर्म बता दिया आपको, या इसमें इंटीग्रेशन ऑफ एफ ऑफ एक्स डी एक्स आप बोल रहे हैं ना, तो इसमें हम इसको वर्ड जो है ना, अगर ये
इसको वर्ड जो है ना, अगर ये है तो हम कांस्टेंट ले रहे हैं। सो डी एफ ऑफ एक्स को हम इंटीग्रेट किए तो क्या आ रहा है, कैपिटल एफ ऑफ एक्स आ रहा है, तो ये होगा इंटीग्रैंड, ये होगा इंटीग्रेशन सिंबल। एंड जो एफ ऑफ एक्स है ना, सो वेरिएबल ऑफ व्हाट, डी एक्स वेरिएबल ऑफ इंटीग्रेशन है, इसको इंटीग्रेट करने से आए वाला फंक्शन है, ये जो है कांस्टेंट है। ओके, इंटीग्रैंड, इंटीग्रेशन सिंबल एंड वेरिएबल ऑफ इंटीग्रेशन बोलते हैं इसको। नाउ इसके पहले बताया मैंने, सो अगर इस फंक्शन को ओके सो डिफरेंशिएट किए तो एफ डैश ऑफ एक्स आ गया, उसको इंटीग्रेट किए तो एफ ऑफ एक्स आ जाएगा। एंड इनडेफिनेट इंटीग्रल्स में लिमिट्स नहीं रहते हैं, इसलिए सी रखते हैं। डेफिनेट इंटीग्रल्स में लिमिट्स रहते हैं, तो हम क्या लिखेंगे, ए टू बी एफ डैश ऑफ एक्स डी एक्स, एफ ऑफ एक्स आया, लिमिट्स सब्स्टिट्यूट करना है ए टू बी, एंड वे ऑफ राइटिंग इज अपर लिमिट माइनस लोअर लिमिट। ओके, सो एफ ऑफ बी माइनस एफ ऑफ ए। ठीक है, दिस इज व्हाट द वे ऑफ फाइंडिंग। ओके, सो द टोटल चेंज वेरिएशन को हम इंटीग्रेशन बोलते हैं। ओके, so now after this we'll see some basic formula students, okay, and then we go for numericals. Now already know integration of d by dx of if you do this, see this particular function, if I differentiate this function d by dx of x power n plus 1 by n plus 1, डिफरेंशिएट करो इसको, क्या आ जाएगा आपको 1 by n plus 1, d पावर d ऑफ x पावर n फॉर्मूला क्या है, n इंटू एक्स पावर n माइनस 1, ये हो जाएगा। एक आंसर क्या आ गया आपको, x पावर n आया। सो अगर मैंने इस d बाई डी एक्स ऑफ x पावर n प्लस 1 बाई n प्लस 1 को मैंने डिफरेंशिएट किए तो मुझे x पावर n आ गया। अगर मैंने x पावर n ds को इंटीग्रेट, क्या आना चाहिए मुझे, x पावर n प्लस 1 बाई n प्लस 1 आना चाहिए, वही तो हो गया, ये तो है फर्स्ट फार्मूला। ठीक है, इसी तरीके से d बाई डी एक्स ऑफ log x हमें पता है 1 बाई एक्स, इंटीग्रेशन ऑफ 1 बाई एक्स इज log x, कांस्टेंट रहा तो इसको बाहर निकालेंगे k इंटू एक्स। d बाई डी एक्स ऑफ e पावर x क्या है, e पावर x, इंटीग्रेशन ऑफ e पावर x होगा e पावर x। मैं d बाई डी एक्स पता है cos x इज माइनस साइन x, इंटीग्रेशन ऑफ साइन x होगा माइनस cos x, बाई वन गेट वन ऑफर। ठीक है, अभी d बाई डी एक्स ऑफ क्या होगा साइन एक्स होगा cos x, इंटीग्रेशन ऑफ cos x होगा साइन एक्स। ओके, अगर फंक्शन कुछ मान लीजिए समेशन फॉर्म में है, ऐसा एफ ऑफ एक्स प्लस जी ऑफ एक्स फॉर्म में है, तो आर यू प्लस वी है, ई को सेपरेटली इंटीग्रेट करो, वी को सेपरेटली इंटीग्रेट करो, ऐड कर लो। एंड अगर कांस्टेंट हो तो उसको बाहर निकालो, सी इंटू इंटीग्रेशन ऑफ एफ ऑफ एक्स डी एक्स। एंड लाइक ए एक्स प्लस बी होल पावर एन डी एक्स अगर फॉर्म रहा तो व्हाट इज राइट, ए एक्स प्लस बी होल पावर एन प्लस 1 बाई एन प्लस 1, एक कोएफिशिएंट ऑफ एक्स को डिनोमिनेटर लिखिए 1 बाई ए, लिमिट्स नहीं इसलिए प्लस सी, इंटीग्रेशन ऑफ 1 बाई एक्स इज इक्वल लॉग एक्स, कोएफिशिएंट ऑफ एक्स को डिनोमिनेटर लिखेंगे भाई ये। Okay, like this, remember the formulas. Okay, now let us evaluate this value now. I was asking integration of, limits are there. Okay, so 10 into, just now we have seen integration of x power n dx, how much, x power n plus 1 by n plus 1. So now 10 into x power 2 plus 1, 3 by 3 minus 4 into x का power 1 है तो कितना हो जाएगा, 1 plus 1 2, 1 plus 1 2, सो 4 इंटू इंटीग्रेशन ऑफ डी एक्स हो जाएगा ना, ये तो क्या होगा, इंटीग्रेशन ऑफ डी एक्स को हम बोलते हैं एक्स बोलते हैं, तो हो गया। सो 10 बाई 3 एक्स क्यूब माइनस 2 एक्स स्क्वायर प्लस 4 एक्स, दिस इज द इंटीग्रेशन ऑफ दिस वैल्यू। सिमिलरली नाउ यू कैन डू, जस्ट नाउ वी हैव सीन डी बाई डी एक्स ऑफ साइन एक्स इज कॉस एक्स, इंटीग्रेशन ऑफ कॉस एक्स, हाउ मच बेटा, इंटीग्रेशन ऑफ कॉस एक्स इज साइन एक्स, लिमिट फ्रॉम वेयर टू वेयर 0 टू पाई बाई 3। यहाँ आल्सो आप लिमिट सब्स्टिट्यूट करना पड़ेगा आपको, यहाँ 1 to 2 फॉरगॉट, सॉरी 1 to 2, यहाँ पे क्या है 1 to 2 सब्स्टिट्यूट करो, या विच इज इक्वल टू 10 बाई 3 इंटू एक्स के प्लेस में 1 to 2 na upper limit minus lower limit. Upper limit is 2 cube minus lower limit is 1 cube. Minus 2 into upper limit 2 square minus 1 square. 4 into upper limit 2 minus 1. Just simplify, that is the answer for the function. ठीक है. Similarly अभी इंटीग्रेशन ऑफ cos x होगा sin x upper limit minus lower limit sin pi by 3 minus sin 0. sin 60 है, sin 6 का वैल्यू कितना है √3/2 minus 0 which is equal to √3/2. बात समझ में आ रही? Yes. Same divide dx of cos x minus sin x. Integration of sin x is minus cos x. Limits कहाँ से कहाँ तक है? pi/2 minus pi/2 so plus pi/2 तो ये हो जाएगा minus cos upper limit pi/2 minus minus बाहर निकालो cos upper limit pi/2 minus cos lower limit cos of minus pi/2 तो हो जाएगा cos pi/2 0 हो जाएगा माइनस cos ऑफ माइनस थीटा इज प्लस cos थीटा. ये भी कितना होगा 0 होगा तो इसका वैल्यू आ गया 0. ठीक है तो हम देखेंगे फिजिक्स में इसके एप्लीकेशंस कहाँ आएंगे. तो हम बोले ऑलरेडी हम देखेंगे कि वेलोसिटी v इज इक्वल टू dx/dt होता है. इसमें से हम dx निकालेंगे v इंटू dt. सो स्मॉल अमाउंट ऑफ टाइम dt में अगर उसका चेंज dx रहा तो टोटल चेंज कितना टोटल यानी इंटीग्रेशन. तो इसको इंटीग्रेशन किए तो इंटीग्रेशन v dt टोटल ऑल dx इंटीग्रेशन ऑफ dx x मिल जाएगा दैट इज इंटीग्रेशन ऑफ v dt. Ready? Like this. So velocity differentiation is v is equal to dx/dt. So if we integrate velocity, what are you getting? Displacement you are getting. Similarly, you can write acceleration, students. How you can write acceleration? Come on, tell me. So acceleration is rate of change of velocity. So dv becomes a into dt. Integrate it, we'll get velocity is equal to integration of a dt. If limits are not there, plus c. So like this, 2 points are remember here. On integrating velocity, you are getting displacement. On integrating, okay, acceleration, you are getting what? Velocity. Okay, that's what I have shown you here. And change in position is always final minus initial. Okay, right. Now see this question. Velocity is given as how much better 2t square minus 40. Find its position of the particle t is equal to 3 seconds. Initial position of particle how much? X is equal to 20. Okay, so at t is equal to 0, x is equal to 20. So you have to be cautious. Now see here, this v means how much beta? dx/dt 2t square minus 40. Okay, everybody. Now dx becomes 2t square minus 40 dt. In small amount of time, change in position is small dx. Total change, total means integration. Okay, from where to where? X is equal to t is equal, this is 0 to t is equal to t. When t is 0, x how much? 20. Any value of t is x. So integration of dx is x, limit changing from 20 to x. 2 into integration of t square is t cube by 3 minus 4 into integration of t is t square by 2. Limit from 0 to t. 0 to t. So if we integrate velocity, what we are getting? If we integrate velocity, we are getting displacement or position, isn't it? The door band kare. So if we integrate velocity, we are getting displacement or position we will get here, isn't it? So it depends. Upper limit minus lower limit is equal to 2 by 3 into this is t cube minus 2 into t square. क्यों 0 हो जाएगा? Upper limit minus lower limit 0 ना. So now this x becomes now 20 plus 2 by 3 into it. What time is asking? 3 seconds. T cube is 27 minus 2 into at 3 seconds. No, this is 9. So now you can simplify further beta. 20 plus 3 9s are no 9 2s are 18 minus 18. Therefore, x position will be 20 meters. Clear? Yeah. Now we'll see what is asking further. That much only, yeah. Find position of the particle t is equal to 3 seconds. So we found position of particle 3 position is 20 meters. Okay. Yeah. Next you see what is asking. Find change in momentum from t0 to 2 seconds if a force acts. By Newton's second law of motion, net force acting on a particle or a body is equal to rate of change of momentum. Isn't it? This is Newton's second law of motion. Proportionality, of course, but after that he shows the value of a system of units. Okay, as k value he made 1 in both SI and MKS system, CGS system. Now force value is asking change in momentum. So what will get change in momentum is equal to simply F dt. So small amount of time, if F is a large amount of force acted, impulsive force, this impulse also called change in momentum. So total change, that is total change in integration F dt. Just now we were saying integration means area. So area under some fx graph or ft graph gives what? Gives the impulse or change in momentum. Getting? So now if I integrate force, what will get? I will get impulse, change in momentum. So integration from where to where? So asking at t is equal to 1 to 2 is equal to 1 to 2. F value how much? 4t square minus 6 into dt. 4 into t square is what? T cube by 3 minus 6 into d by dt of 4. T how much, right? 4 into t cube minus 6. Integration of dt is t. That is t. This becomes 4 by 3 t cube minus 6t. It is 1 to 2 seconds, right? So you can substitute the limits here. 1 to 2 seconds. T value 1 to 2 seconds. Okay. Now if you see this simplified value, 4 by 3 into upper limit minus lower limit. 2 cube is 8 minus 1 cube is 1 minus 6 into 2 minus 1. 7 4s are 28 by 3 minus 2 minus 1 is 1 6. Just simplify. Okay? This is the word change in momentum. Now you see you're asking find the area between the curve y is equal to x cube and x axis from 0 to 3. Just now we have seen area of irregular shaped things was found by dividing the area into small elemental areas. You can divide small elemental areas. Take once a small elemental strip dx. When dx is very small, this approaches to a single value, that's some y. So small area dA becomes what we said, integration y dx actually, isn't it? Actually what? Small area is length into breadth, no? Small y into dx is y dx. Total means what? Integration. Okay? So y value is given, that's for total area is integration of y value how much? X cube into dx. So integration of x cube is x power 4. Limit from where to where? 0 to 3. This becomes 1 by 4 into 3 power 4 minus 0 power 4. 81 minus 0. So what is the value you get? Substitute there. This is the total area, square units. Okay? This we'll find out. Now, for example, just now we have seen, now once again the revision you see here. If you differentiate position, you are getting velocity. If you integrate velocity, you are getting position or displacement. Now acceleration is dv by dt. So dv is equal to a dt. So total change means integration. So integrating acceleration, we are getting velocity. So if a is equal to 60, so for example, find velocity at t is equal to 0. Okay? So now I can find out initial velocity. So what you can take? dv by dt is equal to 60. So dv how much, right? 60 dt. So total change means integration. Okay, starting velocity v to any velocity v. Or some mention you get 2 seconds by giving that at t is equal to 0, velocity 0. You can give condition like this. Say particle starting from rest, है ना? पार्टिकल रेस्ट में से शुरू हो रहा है, 2 सेकंड्स के बाद उसका वेलोसिटी कितना है, हमें क्या दिया गया है? एक्सेलरेशन दिया है. एक्सेलरेशन को इंटीग्रेशन करने से क्या होगा? हमें वेलोसिटी मिल जाएगा, है ना? तो हमें क्या करना पड़ेगा? अभी dv इज इक्वल टू 60 dt है. सो इसको इंटीग्रेट करो कहाँ से कहाँ? कुछ 0 to 8 30 सेकंड्स मानो. तो यहाँ dv इज इक्वल टू इंटीग्रेशन t इज इक्वल 0 के पास हम मान रहे हैं वेलोसिटी रेस्ट में है बॉडी, t के बाद वेलोसिटी v मानेंगे, तो ये हो जाएगा 6 इंटू इंटीग्रेशन ऑफ t कितना होगा t स्क्वायर बाई 2, दैट इज 0 टू व्हाट t सेकेंड्स, दिस बिकम्स 3t स्क्वायर. Getting? So 0 to 2 seconds means t becomes 2 seconds. Substitute here. So 3 into following. So 2 square. 2 square means how much, right? 2 square means 4, which is equal to 12 meter per second. Okay. So like this. So just summary. Integration is a technique in mathematics for finding the area of irregular shaped objects. फाइंड आउट करने के लिए इरेगुलर शेप्ड ऑब्जेक्ट्स का एरिया फाइंड आउट करने के लिए हमें इंटीग्रेशन टेक्निक यूज़ किया गया है. ठीक है. सो उसमें से हम कैसा एक्चुअली एरिया फाइंड करना है, टोटल एरिया को स्मॉल स्मॉल एलिमेंट्स में डिवाइड करना है. ओके, फॉर स्मॉल एरिया डी ए हो जाएगा, उसको इंटीग्रेट किया तो टोटल एरिया आ जाएगा. ठीक है. उसके बाद हम फार्मूलाज देखे हैं पूरा एंड सम एप्लीकेशंस न्यूमेरिकल्स वी हैव सीन. So basic idea what is integration, how do we do. So conclusion in physics that integration acceleration will get velocity, integrating velocity will get position. Okay, so differentiation and integration, they are inverse in sense. Just this much you keep in mind, that is more than sufficient. And later ones, so in actually in mathematics we'll learn in detail, but after some time, it may be in curriculum, after 6 months we will learn, but its applications require in physics, because of which we are teaching under heading of mathematical physics. ठीक है. And a few more applications, so like we consider a small amount of work done in displacement object is f dx. Total work done how much? This is dw. Total means we'll go for integration. Understanding? So this one example you can take. So force as a function of time or position. So for example, f is given, f is varying like this. For example, this I am saying. Okay, so this is 0. So with position x, sum of 2, this is 2 meter, this is 1 meter. So f value here is some constant of 10 Newton. So slowly force is linearly increasing, become maximum, then force is constant. So what is the, if we ask work done by the force, so here force is variable. So for variable force we use the formula integration f dx formula. Okay, again you don't worry. So in laws of motion, work and again we learn these techniques. Okay, so now integration of dx, this is area under fx graph. Area under which graph? Fx graph. This is a trapezium, this is one parallel side, this is another parallel side. So formula is half into a plus b into h. Then it, so half into a, one parallel side, 2 minus 1 is 1 plus b parallel side is 2 into h separation of mother is equal to 10. So 3 by 2 into 10 is 2 1s are 2 5s are. So 5 and that's no. 3 by 2 into 10, no, 2 5s are 3 5s are 15. This is, you can say 15 joule of work is done. So area under fx graph gives what? Work done. Keep in mind this one. Okay, this is what simple. I try to just convey the message of physical meaning of integration and how to find basic formula. Its application in physics: when position given, differentiate velocity, integrate velocity, position. When velocity given, differentiate velocity, acceleration, integrating acceleration, get velocity. Okay, understanding all of you? So this technique you can know. Fine. Yeah. So please do subscribe and share my channel and share your opinions also. You can post some doubts also if you're having basic things. I will address your concerns. Okay. Right. Thank you all. Good day.